It's impressive. We still don't have self-driving cars, at least as I record this video, but there's a sense in which the whole enterprise feels far closer than it was in 2004. One of the ways that people like to conceptualize this sort of trajectory is not only that the technology improves, but we get more certain over time as to what a technology might do. And you can see here, with regard to robotics, how someone's mapped out this cone of uncertainty. In the consumer market, we had products like Lego's Mindstorms, and then we had the Roomba, and Sony Aibo. It was a little dog that I used to have one, and it was retired, but it never really worked that well. But it cost a lot of money, so it's good. The Roomba actually had evolved, and circa 2007 and certainly today is a common household item, and therefore from 2007 onwards you might have seen that we might have had more robots occur and stuff like that. Now, it's interesting. They say that the Steve Jobs of robots would have arisen around 2011. If that has happened, I'm not sure who that is. But this is the interesting way that this trajectory in the cone of uncertainty is working. As you progress, you learn more about the technologies and you see more about what the potential applications are. And that's part of a technology trajectory there. So the key question is, how can you go beyond broad speculations, which we've just shown are an issue, and have a meaningful forecast of how fast particular technologies are likely to evolve? The answer is we actually have a tool. The pattern was noticed by this man, Richard Foster, in a book called Innovation, the Attacker's Advantage. They're not all dilemmas. The technology S-curve, it's like the market S-curve in that it's an S given by this logistic function that was familiar there. But it has different things on the axes. On the x-axis is a measure of input, effort, resources, or investment. On the y-axis is a measure of performance. Might be a metric or might be a host of metrics. And so it shows that when you get a technology for the first time, eking out performance improvements takes a lot of effort. Then comes a time when things start to fall together. Often that is associated with what's called a dominant design. You suddenly start to realize what a technology should look at. Want to know what a dominant design is? This is a dominant design. Back in 2007, no one knew what smartphones should look like. Steve Jobs then invented it. Who knows what I've shown there? Once you do that, effort has high returns in terms of performance improvements until you reach some technological limit. Now, as with the market S-curve, we don't know when the takeoff's going to be, and we don't know what the limits are for any given technology. But we do have some inklings as to what might drive those things. Let's apply this to a case that you may or may not be familiar with, but at least can imagine if you're not. I'm intimately familiar with this development. This is the evolution of the disposable diaper. Diapers had a previous technology that some people still use, cloth nappies. Any parent can tell you what the downsides of that are. So in the 1940s, there was a push to have a disposable diaper that you can see there. There was not much to it. It was just going to catch what they call the insult and allow you to dispose of it. It was quite a large object. In the 1960s, Pampers came up with a more absorbent thing that would keep babies happier, but it was again a very big item. Then in the 1980s was a big breakthrough for super absorbent polymers that allowed much smaller diapers. And by the 2000s, the diapers were another 60% smaller than that. As you approach old age, you're going to be grateful for all this innovation occurring. So we can plot this out with R&D effort on the x-axis and absorption capacity, and by that mean how much liquid can fit into this thing and be drawn away from both the outside and the inside of the diaper, plotted. And you can see the S-curve for the initial technology before we got super absorbent polymers. When we got those polymers, this is what happened. The initial patent was in 1966. That was just after the breakthrough that Pampers had. And you notice the Pampers wasn't wiped out by that. It actually had most of its growth in the next 20 or so years. However, then it was introduced, the SAP versions were introduced into the market, and you'll see that they've gone all the way to their maximum absorption around about today. So I guess the industry is ripe for more innovation there. We see these sorts of relationships also in other areas. One famous one is Moore's Law, which talked about the doubling of transistor count every 18 months or so on microprocessors. As you can see here, and it looks like a straight line only because we have a logarithmic scale on the y-axis, is you have exponential growth pretty much from the 1970s up until just a few years ago. Now, are we still in Moore's Law? It's hard to know. We don't have the same transistor doubling going on. You can see it's bunching up there at the top. But we now have the ability to have faster processors using multiple cores, and also by helping for certain applications with graphic processing units as well. So there is still an increase in computational power going on, not to mention what is going on our mobile phones. So Moore's Law definitely doesn't refute it, and as you can see there, if we it accelerated, it was slow going at the beginning, lots of gaps between in performance in the middle, meaning that it really grew very quickly for small amounts of effort, and now it's sort of started to peter off. So Moore's Law is yet another example of the S-curve occurring, even though right in the middle of it all occurring, people wondered if there was a natural limit at all. Like the market S-curve, the technology S-curve is also fractal, in the sense that it's made up of a whole lot of little innovations. And so for you, you might be not talking about being on one big technology S-curve versus another with your startup, but in fact being on one of these smaller ones that go there. It all depends on what the product, the application, and the technology is. It's just that this relationship pops up again and again. Now the key strategic insight, the thing that, this is S-curve is a technical constraint, but the key strategic insight comes from looking at this. When you have an old S-curve that many established firms are better at moving along, it often outperforms, at least certainly initially, new and more promising technologies. What this means is that startup firms may well have a better opportunity not to go along the existing S-curve, that's where established firms already know what they're doing, but in fact to switch to a new S-curve. Now they'd have to sacrifice some performance level, which has some implications for the customers they target, but this may allow them to outclass the established firms into the future. Again, this happened with smartphones. The established firms of Nokia, BlackBerry, Motorola, and Ericsson all were on an existing S-curve, whereas Apple, Samsung, HTC, and others were on a new S-curve. Now that played out remarkably quickly. Most of these things are not so fast. Well, how does this relate to another place where these technology trajectories come along? That's in disruptive innovation. You may have already read about this. Clay Christensen, depicted here, also looked at time and on the y-axis was customer value. But it was also related so intimately to performance, because that's what the customers value. An established technology may do better than a disruptive technology, but a disruptive technology over time can actually have a faster rate of improvement. And that allows someone adopting that technology to compete with the established technology. In other words, it works a similar way to that window of opportunity, and so it's one special class of that. This is something we'll definitely come back to in a later lecture. The other way to think about this is not just simply in customer value, but in fact those opportunities can come on the supply side. This are some graphs from a study by Rebecca Henderson looking at the improvements in photolithographic alignment, a particular equipment that was critical to building microprocessors and semiconductors. You can see here that the resolution, which was the performance metric, increased quite steadily from the 1970s to the 1990s. But what was interesting is it did so over 4 different, effectively S-curves going on. What you might also be surprised to know is that there was a firm, Canon, that managed to be part of the market leadership in every one of those 4 generations. You can read more about that in the readings. But what that just suggests to you is, while it's the case with demand-side disruptions, as they might be called, that there are opportunities for startups, with supply-side disruptions, it's a little bit different. There are opportunities, but it can also be the case that established firms can have capabilities that allow them to be flexible and to leap across different technologies. Those things need to be taken into account when choosing your technology. In other words, the technology could shape the competition you have with established firms. A question that we'll come to a little later is, do you want to compete with them or not? Up until recently, the S-curve was really taken as an environmental fact. It's just a technical constraint and you had to live with it. But we've wondered recently if it's a process that can actually be managed. For instance, just ask yourself, what choices might result in a particular technology S-curve for a given idea? The S-curve is really made up of 3 stages. There's an exploration stage, where you're working out what the technology is all about and what it can do. There's an exploitation stage, which I already described, where you get into a situation where you understand that and you put all of your technical energies into making it better and making it able to be in products that can go to market. Finally, there's a stage of maturity where all the innovation looks very incremental, but it's all off a very solid base. The question is, can your choice of technology and the choices you make right up front impact on how long the stage of exploration is and how long the stage of exploitation is? And there's likely to be a trade-off between the two. In other words, you may face this: a technology that has a given performance right now, but depending on what you do, may have either a very rapid performance but peter out, or a longer run performance but gets you to a higher place. There are trade-offs here. For a startup where you're trying to make your mark in a market where performance matters, you may be tempted to do things very quickly. The question you have to ask yourself is, are you mortgaging your future by doing that? So you have to go from figuring out whether a technology is disruptive to actually going and choosing a disruptive trajectory. You could choose something that is in fact not so disruptive but compatible with established firms. One special case of this is minimum viable products. This was a term introduced by Eric Ries in the Lean Startup, and a lot of startups these days who pursue particular entrepreneurial strategies, again, more of that later, actually are very keen on putting out products that allow them to experiment, allow them to interface with the customers, and allow them to move very, very quickly. In other words, what these products do is they move you quickly past the exploration stage and into exploitation, where you can improve very rapidly. Now that's a good idea, but the problem is, if you get put on that path, will you stunt your growth into the future? If you choose code or something else that allows you to ramp up right now, will that harm you getting to scale later on? This is a trade-off many startups face. So finally, choosing among technologies isn't an easy thing. It's in fact one of the more difficult set of choices that you'll even want to realize, let alone work your way through. The first step is to understand that you've got distinct technological choices and to compare them, especially regarding performance and trajectory trade-offs. You want to be able to actually pick those performance metrics such that they actually matter in the market. That itself can be quite a difficult exercise. Do you want to align yourself with the performance metrics of the industry, or do you want to choose consumers and choose your customers and move them along to other performance metrics? Again, that all depends. It depends on your other choices. You also have to assess the cone of uncertainty. You have to realize that technologies are uncertain. While it's tempting to think of something as disruptive just because it doesn't perform well but has some nice features, that doesn't mean it's got the underlying basis to have a very rapid trajectory of improvement. Instead, like many good ideas, they may turn out to nothing, and so you might be left with low performance and no improvement trajectory. You're going to need some technical expertise and some heavy guessing to work your way through that. Finally, the way you should approach this is, once you've identified these S-curves and once you've assessed their degree of uncertainty, you have a choice. And that choice is related to all the other choices in entrepreneurial strategy. So this will be nicely nested in all of that. That said, I want to leave you on a thought that we've come up with time and time again. There are many worse business plans than predicting Moore's Law 3 to 4 years out and then designing technology and building a company around that. If you're close to using computers, IT, or anything like that in your business, this is perhaps something that is good to go by.